Okay, so hello everyone. This is Jeffery Zhang from the GIS International Training College. Today, I'm going to show you a topic for SuperMap 3D GIS empowers smart water conservancy. So for my presentation, I will have three contents. The first content, I will show you the current situation and the challenge of how to build the water conservancy management. So from the beginning, I will show you the objectives of the construction. So how to build the 3D smart water management platform? The first base platform is to process the data. So for the water conservancy data, we have the different types. We have the building information modeling, we have the beam data, we have the vector data, and also some data from the UAV. And currently, we also have some data from the video and even from some attributes table, some certificates documents, and some satellite imagery. So it's the final target is to manage all the data in one platform. But here we also have some challenge when we manage this kind of data, because some data is for the underground. You can see the outfall data, the meteorological data, and some facilities data. And some data is on the surface. We have the soil data, we have the water surface, and other data we have underground data, like some pipeline, some geological data. So it's a little bit challenge to manage the different type data, because the data is different, and also the format is also different. So from us, first of all, we will provide you a solution to manage the multi-source data, and especially for the 3D data. For the 3D data, we provide the multi-source data integration technology. You can see from this page, we have the vector data, we have the point cloud, we have the building information modeling. So if we want to build a management system, we provide several abilities. First is for the data conversion. We can convert the format, can do some data processing, and then we also have to set the correct coordinate system. We have to do some transformation for the coordinate system. And also we need to unify the data standard to satisfy some international standard for the data. And the last one, because for most of the project is based on web terminal. So it's very important to provide a good way to achieve the model lightweight. So you can see from this page, this is several effects that we do the database construction based on this four technologies. This is some optical photogrammetry based on the terrain data, and also we did some integration for BM data and terrain data. We use some spatial calculation and do some modification for the terrain, and then for the water surface, because if we use the drone to collect the data, usually the water surface is not good from the result because the water surface is dynamic. So here we provide a new choice for you. You can use some vector data and set some water surface symbol to achieve the dynamic water surface effects. And this is some effect to build the 3D digital water conservancy facilities by using multi-source data. So this is one of the hydrology station from China. And for BIM data, we also provide more choices for you. So currently we support the most mainstream brands for building information modeling. Like, as you know, we support the Revit, a Bentley, a Civil 3D, and Dassault System software, and also for some other format like CDGML or FC format, we also support the input in our platform. And after you import some BIM data, it is highly suggested to use it with GIS system, because for BIM data, you can do some maintenance, you can do some planning or construction management. But for GIS system, you can do more, like some 3D spatial analysis, some operation, and some resource integration to empower your database and your management abilities. And this is several effects for the multi-source data integration. You can see we have the beam and terrain data. We provide this ability to combine with these two data, and also beam data with optical photogrammetry, beam data with water surface. Even for some CCTV video, you can also connect it. And for some bridge and the river infrastructure, you can also use the BIM data to manage them. So this is the effect. And you can see we load the BIM data here and with the water surface data. And this is a demonstration to show you how we combine the BIM data with the terrain. You can see now we have the BIM infrastructure, and then we overlay it with the mountain terrain, and we do some 3D calculation and modification based on the terrain data. Okay, for when we talk about the 3D calculation based on some terrain data, here we provide a good effect that you can do some 3D bowling operation for some hydropower facilities. You can see this is an effect that we use these two data to do the spatial calculation. And even from the underground, you can see we do a bowling operation based on the terrain data. And after we talk about some BIM data, then let's see some other data type, that is optical photogrammetry data. And from these cases, you can see it's an integration of 3D model and optical photogrammetry data. You can see we use some SketchUp data we input here, and we do the seamless integration for these cases. And after we talk about some data integration and multi-source data, now I'm going to show you some applications for smart water conservancy management. So when we talk the water conservancy management, the first target is to do a overlay, or we call this one map management. That means we need to integrate all the data source, all the web source, to manage it and to put it on a uniform a platform. So here, before we build this one map, we also provide some options for you to extract the data automatically. So this is an effect you can see. We can extract the water system from the satellite imagery, and then you can get the water system area or other, like the farmland area. Then we provide you a product or a technology. You can do the a dashboard. We provide you with some control bar. You can drag it here directly. You don't need to write any codes here. Then you only need to do some parameter settings. Then you can have this dashboard and publish to web terminal. And except the one map, we also provide you some ability to do some analysis, especially for the water conservancy domain. So first is a flooding analysis. So for flooding analysis, the first step is to get or collect some or connect some water forecast data, and we get the weather data, and we use this data to analyze the raining area and to do some prediction. And then we can build some flood risk prediction model to calculate the area based on the map. And then we also can visualize the effect based on the timeline to simulate the water flooding area. For some 3D technology, we also provide you to do it on the iDesktop platform. You can see here we can simulate a raining area here. And for other applications like the high risk area analysis, you can see we can also based on some terrain data and also the imagery data here. And after we get the terrain data, we also provide you some abilities to do the flooding analysis for some urban management. You can see this is also a simulation for the flooding analysis. And for some mountain area, we also provide you the ability to do the flooding analysis. And for some emergency situation, we can also calculate the optimal path to do some transportation to send some goods for the affected area. And also for some water conservancy management, it's also need to do some geological analysis of the basin. So this is a 3D geological body model to do the construction in our platform. And you can see we use some sample points to do the interpolation, and then we can generate the 3D model here. And after we do the geological body model, you can also have some visualization effect, like to separate it, to see the different material on layer. And for some city management, and then we will go to the management for the water conservancy facilities. So for the facilities, we need to manage the terrain data. We need to manage the bridge data, the canal, the roads. And also for some situation, we also need to do the safety monitoring of the underground water tunnels. So this is a effect to see the tunnel monitoring dashboard. And for some statistic and prediction for the water level change in monitoring station, we also provide you a dashboard to visualize this effect. And this is also the simulation of the water level change. And for 3D analysis, we also provide the spatial measurement. You can measure the distance, measure the height, and measure the area. And for 3D port management, we also provide you a full ability to manage the transportation, to manage the whole area for the port. And for other applications, like the 3D grid, you can also use the voxel grid of us. So for voxel grid, you can do some like the bed sediment change based on the a voxel grid to do some analysis. So you can see this effect. Now we have the satellite imagery here, and we do the 3D interpolation for the bed sediment, and we do some analysis based on some points. And for more, when we do the facilities management, it's also need to combine with some IoT equipments. So this is some sensor connecting to monitor the power generation in real time. And also to check the real-time status of a power station and some equipments. For more, you can also connect the CCTV video. So this is an effect to connect the hydropower station and to do the monitoring. And here we will provide you a cases to do also connect the CCTV video. And this one is to manage the river basin to do the monitoring. You can see you can connect the different CCTV video from the different station. You can see if we click the station, it will connect the real-time video. And this is also another cases from us. It's also to monitor not only for the security situation, but also for some like the water level monitoring. You can also you can see it's easy to see it from the camera. For more, recent years also released many new technologies. Game engine is also one of the popular technologies. You can see now we support Unreal Engine and Unity Engine, because if you only visualize the data in GIS platform to do some analysis, you cannot get very good effect than game engine software. So now we released a new plugin. You can install this plugin in game engine software. Then you can have the ability to load the GIS data in game engine, and also to do the 3D spatial analysis in game engine software. And this is an effect to do the water conservancy facilities management. And for other emergency response analysis, here it can also use some drone to monitoring the illegal sewage discharge of the river or the water surface. And for more, like some emergency situation, we also provide you a 3D ability or technology to do the simulation for the whole accident. And you can see this is also one of the cases from us. So that this boat meets the strong wind when the boat's shipping in some area, and then finally is make a very heavy the accident in this area. So after this accident, we use this platform to simulate or to analyze the reason or the factors for this accident to avoid for any other new cases. So you can see we simulated by the time. We can add the dynamic weather effect, the water surface effect, and also add some real-time shaping schedule to combine with some other shaping to do some analysis. We add the wind effects here. And finally, this shape loads the energy, and the water come inside the bowls, and to this accident occur. For other emergency situation, like the chemical liquid spirit, can also analyze the spirit area and analyze the affected area from the 3D technology. Okay, so that's all for my presentation for the smart water conservancy management. If you have any questions, please feel free to contact me. Thank you.